And today we have three fantastic speakers, but our first speaker is Roman Mierson, who is Jack of Initiative Driver. Other than that, he is host of 3 podcasts. Roman, I suppose you even have more podcasts about Java, but at the moment it's Java Hot, Java Late Night, and Genius. And there is another important thing which Roma drives. It is Java On conference. Have you been to Java On last year? It was a great conference, right? And I hope this year it will not be worse. It will be definitely better. Because Roma, we're doing it together, aren't we?
Yeah, exactly.
So before we start, just a short question. Ruslan, I know I already heard Roman's speech, and it's about reactive programming in Java.
Yes.
But I know you're a Python guy. Is it possible to write in reactive style in Python?
Yes, of course it's possible, but we call it not reactive, but we call it asynchronous code. Coroutines and other stuffs. Yes, and to be honest, we have coroutines from, if I'm not mistaken, from 2005.
From 2005. Well, it's almost from the very beginning.
Yep.
Yeah. Well, as ordinary Java has a long history, there are many trade-offs in it. So reactive programming, let's say, is something in the middle right now. It's still popular, but maybe new virtual threads will help, let's say, make life of our engineers better. And I suppose Roma already had a great opportunity to work with it, and he collected a lot of problems, use cases, impediments, and definitely obstacles of writing reactive apps.
Yeah, from my point of view, you Java developers are really proud of Java JVM's reading performance and reading power. And most of my Java interviews touch this topic. So common question was, can you please implement single tone in read safe manner or something like that? And but now in modern world, threads are not only a way to provide concurrency to our application, because we have a lot of outbound operations, whereas threads is not the silver bullet, as I know. And on the other hand, you cannot run thousands of threads. And Python, as I said, already has this new, it's not new, this paradigm as concurrency, coroutines, and so on. And I heard that Java has Project Loom or something like that to bring it to JVM. But I'm wondering how Roman will achieve concurrencies in Java without Project Loom is implemented right now.
So Roman, if screen is yours, so please share the screen and tell us a little about your.
Before I start, guys, I want to unhide some internals from your community. So like Ruslan wrote me, I think, a couple of days ago and say, okay, I watched your talk, it's amazing, but unfortunately we have only 45 minutes, so like you have to fit. I said like, okay, no problem. And now they're speaking for 5 times of like benefits of this in Python. So thank you guys, nice introduction, and really thank you.
Welcome, Roman. Welcome to our community. And we will interrupt you a couple of times.
Sure. So like non-ironical, thank you very much, guys, for inviting me. It's pleasant to be here. So just to say, when I will have presentation, I will not have a look in the chat, so feel free to interrupt me, and if it would be possible, let's leave questions to the closer to the end, but still you may interact actively. It will be live coding session. I will write some code. So if you see some errors, just feel free to tell me about them. So let's do it together. On the screen, you may see a GitHub page with this project. So I will post a link to the chat. It's there. So you may visit it after the talk. I think it does make sense to visit right now. So you may visit after the talk. Please put me some stars, maybe, if you make it possible, if you feel it possible, so I will know that it's helpful and that I'm not doing it just for myself. So let's start. My talk called Your First Reactive Rakes. So hi everyone, my name is Roman Mierson. Please call me Roma. I'm a chief software engineer at TPAM Spain. I work with Java since 2010, quite a lot. I'm driver of Jacob community, and here's my Twitter. While it's still live, feel free to subscribe on me. Sometimes I post something there. Not always, but sometimes. So for whom this talk is? Possibly you've heard a lot about reactivity in Java, and maybe not only in Java, and you never tried it yet. So then this talk is for you. You will know more about it and how it works in Java. Maybe your colleague dream is to bring reactivity to the project, but you have doubts about that, then definitely this talk is for you. You will know something which will brings you some arguments about reactivity and for discussion with your colleague. Maybe you are that exact colleague who want to bring reactivity to the project, then yeah, this talk is also for you. You will see some drawbacks or some rakes you would have to step when you will work with reactivity. Or maybe you use reactivity in your project and already took some lumps on it, but there is still some empty space left, then yeah, this talk is also for you. Who may go and do something more useful? Well, you have other talks to wait for, but still, maybe you can do some useful in the time of my talk. So in near like 30, 35 minutes. So if you're a WebFlux developer, then definitely you won't find anything interesting here. You had brought reactivity to your project before it became mainstream, then this also talk won't be really useful for you. There is no place in your body for new reactivity lumps. Same thing. Or maybe you think that ChatGPT will replace all developers soon, then probably you need to running around, winning around, and complain about ChatGPT and how bad world is. But still, here we will discuss engineering stuff and reactivity and all these parts. So, just a reminder from the small discussion we had before the talk that Loom is coming. So basically, these are virtual threads which will be publicly released in Java in this September. There is also a preview feature now, so you may download Java 20 and try it, but in Java 21 it will be released fully and it will be in production, could be used in production. And we on our community, Global One, Jacob has a talk from Alexander Filichkin about Project Loom. So if you don't know anything about that, feel free to go to our YouTube channel and have a look at it. I may post a link to the chat later if you don't know where it is located. So let's come to our topic. And what do we have? What will we work with? So we have old, boring, classic web service, like very traditional, with Spring MVC inside. So I'm pretty sure you wrote something like this several times, not only several times, a lot of times in your life. And we'll have new shiny reactive service, and we will do stuff around them. And we will have several cases, which we will try to open with you and see how it looks inside and how to work with this. As Nicholas Wirth said, programming is usually taught by examples. So let me switch to my IntelliJ and show you some stuff. So here we have our classic web application. So let me open POM XML and show you that we have here Spring Boot Starter Web. So it's kind of classical one, very traditional, nothing special about it. So everything is very like classic, right? And here we have the MVC controller with some methods, which we will call from our reactive application. So we have here like some method, which just returns string, some post method, which returns string with something, some method which return that data, but with some delay, and some error, some fallback. So we will discuss it when we will come to them. So this is our old application. And also, we have our reactive shiny application, new one, right? So the reactivity and all we want, and then we go to POM XML, and we see here, we have here WebFlux. So basically, this is the thing we desired for, right? This is some reactivity, some modern words, something new and cool in our project. Yeah, and I have some controllers here prepared to discuss them. So we'll have a look at them a bit later, at least on as many of them as we have time for. And our case number one time try, not reactive. So what we will have? We have our new shiny reactive service as always, and old one. And we have web request coming to new service, and we want to make another request from new one to old one to get data and provide it back to the user. So quite simple, right? You have some old service in your system, you build the new one based on reactivity, and you just want to build it as a proxy for your service, for your request. Okay, let's have a look into the code. For this, we have this controller. So here we have like a method prepared hello forward, which is not implemented yet. So we will implement it. So if you are like seasoned Spring developer and you come to reactivity world and the question like, how should I do, what should I do to make a request from one service to another, the answer is pretty easy, right? There is REST template, which gives us ability to make this request. So we go to our like base application, and here we define a REST template. So everything is quite traditional one. We just define this bean so we can use it. Okay, done, it's here. Now we go to our controller. Here we need to outwire and here we go with private REST template, done. So we outwired it, and now we need to call it, right, to make a request. So if you do it like in normal traditional way, you just go for REST template. By the way, let me start the classic application so it will be up and running, so we would be able to make a request to it. So you go for REST template, then then you call get method, get for object. Let me close this one. We will have a look at it later. So get for object, then you need to define URL where you want to send this request, http / we have our old application on localhost 80/API / hello localhost, no mistakes there. And then you go with like string.class. And that's it. So this is how you get the data from like in normal world. But now we are in reactivity world, and our method tells us that we need to return mono, right? And this method returns a string as we call for string.class. So we just go here and say, okay, we need to return mono dot, and then there is like this mono.just where you provide the data and like cover data into the mono basically. So we say mono.just, and then we go for this one and post it here into mono, and that's it. Looks like we wrote some reactive code. Yeah, looks good, by the way. So let me start our application, and let me check if I share my screen without sound or with, just to, yeah, I'm shared it without sound. Nice. Okay, so our application failed to start. It says that consider defining of bean of type REST template builder because it wasn't found. Okay, some error happens. If something happens with this error, with that question, I went online, and if you Google that, then you will see that probably some Maven dependency is missing. And you see on the second link in the Google, like Spring Boot Starter web is missing. Oh yeah, exactly that. Like how dumb can I be? So I will go just to POM.xml. So here we have WebFlux. So Spring Starter web is missing. So I just copy that Spring Boot Starter web, right? So I just add it, and let me restart my reactive application. Let's see how this looks like. Something is missing again. Let me check what exactly. Okay, yeah, I need to rebuild it with Maven because I've added a dependency, but it wasn't imported. So quick build. It takes a couple seconds. No test there.
It's a trap. It should not work this way. It's a trap. It should not work this way because the Spring REST template is not reactive, by the way. It's deprecated and.
You're running too fast.
Yeah, I know. Because I faced this rakes many times already.
Yeah. So basically, our application is started. So it's started. It's able to compile. So let me go here and call this request. And I have the data from my old application. So if I have a look in this API hello in my old application here, it like returns hello from old MVC. And basically, I have this request. So looking into that, you may think like, okay, I wrote reactive code, like it's reactive. So, and I developed reactive application. and you didn't use blocking calls, right? Right? Well, basically, all this thing with reactivity and all this stuff is just to avoid a problem with thread starvation. Because when you have your old classic application, your threads, your calls are based on like regular old classic threads which are there. And if one of your requests is taking too long time, then you have -1 thread in your thread pool. And if you have several threads, all of them which took a lot of time, then you are out of like threads. So you have no ability to process anything in your application. And here we have reactivity, which says, okay, let us build pipeline and we would manage these threads by ourselves inside our thing. You don't need to care about that. Just build a pipeline and do that. Only thing I ask you, not use any blocking calls inside that, because then you will ruin everything. And then we use this REST template get for object, which is definitely blocking call because it's old and bold, right? So this is not a thing to do. By the way, I did the same talk a couple days ago or previous week, I think, on our global community, and guys told me that REST template is now deprecated in favor of web client, which we'll have a look at now, because web client could be also blocking and non-blocking. So this code is definitely not right. So let's make it right. To make it right, we need to go to our POM.xml and get rid of the Spring Starter web dependency, because we are in the reactive world. We don't need that. Then we go here, remove this REST template bin, so we don't need it anymore. We go to web client controller, and we don't need that REST template and all this stuff. So what do we need? We need to define web client, the thing which we will use to make a request, which supports all these calls and able to do this like in non-blocking way. So we define web client, and in the constructor of this class, we say that, okay, web client.builder base URL will be localhost 8080/API. So we build that web client. Now in the method, we say, okay, we already have web client. So for this, we need to do get method. Then we define that URI will be /hello, as we already have localhost /API there. Then we say that we would like to accept media type application JSON, and then we say that we want to retrieve data from it, and then we have method body to mono, which already converts for us body, which we receive to mono of some class, and then we have like to define here that we will receive string here. We don't need this row anymore. And then here we just put return. So let me restart application. So now we have a special class web client, which gives us ability to do non-blocking calls and already cover our response into mono. Okay, application started, everything's good. Let me run it. Yeah, hello from all the VC. So you may think, okay, in previous run, we have the same result. We received this hello from all the VC. And then this run results is also the same. Like, what's the difference? You basically won't see the difference on this example, because here I just show you how you can code this. But if you have a huge application where you have a lot of calls, and call is not only just like a proxy, but also do some actions on all the applications, so it takes time, you would see dramatical difference between pipelines where you have blocking calls inside and between those where you don't have that. So this is the thing you should be careful of. And coming back to my presentation, we had a case which we called one-time try, not reactive. Basically, if inside one application you do reactivity, that means that one-time reactive, always reaction, always reactive. This is not my quote. This is quote of great speaker Mitya Alexandrov. He is developer in Oracle. He developed Helidon project and great speaker. Find his talks on YouTube, and also he was a speaker on our previous Java conference, which was in December, which Alexander already mentioned. So yeah, find his talk there. He spoke a lot about Helidon project reactivity and also about Project Loom. It was quite interesting. Moving on to the case number 2, which is called how long do you work? So what we'll have here, we have new shiny application, old one. We have a request coming to our new application, then another request going to old one. But what we want to do, we want to know how long does it take for a second request to work. So let's say this old service is not our service, but some third-party service somewhere. And we want to be sure that about the time, how long our request works there. So if some customers or anyone will come to us and say, hey, why your application so slowly? Then we'll say, okay, it's not our application. Here's your third-party service you suggested us to use. Here's the logs of the time. So go blame them, not us. Okay, let's have a look at the code here. So I have another controller prepared. Here you may see I have time lock controller, web client, we already discussed it. Here we do get for like some URL hello with delay. Let me show it to you. So here we also return hello from old MVC with delay, but we also do sleep on random time from half millisecond to 1 second. So this is important. Then coming back to our reactive application, let me just close it here. So coming back to our reactive application, this one, we do call on hello delay, accept application JSON, retrieve body to mono, and then we do some mapping on our side. So quite easy and straightforward, right? So if you want to track time in your production, you would probably not do it manually, but you would probably use some library which exists somewhere. And one of the most famous is micrometer. And by the way, micrometer is included in Spring Boot 3 by default as a default library. So now you don't need to add a lot of dependencies on using that. And if you Google how to log time in micrometer, you will see kind of this doc. It says that, okay, just wrap your code into the Lambda and put it inside the timer.record, and then we do all the stuff for you. So basically, we just wrap all the code we need to do into runnable or callable and provide it to timer. So basically, just wrap your code with 2 time tracks. So of course, we won't use micrometer for our example, but we would use something, we would do something really close to that. So let me go here. So here we would, let me just copy it, do this like that. Okay, so we track time before, then we do our call. Yeah, here, let me do that. And of course, we need to wrap it into variable and provide result like after. So we do track time before, then we do our request, track time after, and have some logs here. Right, so code is looking quite simple and quite straightforward. Let me restart my application. And let's see the result we will have here. Okay, it's restarting. It started. Let me run it several times. So run number 1, run number 2, and let's say the run number 3.
It will, but incorrectly.
Yes, exactly. But it will not work correctly.
Guys, you're too smart, you know, and running too fast still. So let's have a look at the logs to prove or disapprove what you were saying. So first call was running for 21 milliseconds. Okay, still a question that we have sleep timer on our old application from half a second to 1 second, but okay. But what about other calls? 0 millisecond, like some nanos here, and is here also 0 millisecond, some nanos here. Okay, something is definitely wrong, and guys spoiled it for you. So we definitely not track time right. But what exactly do we track here? So while doing that, and when we write code like that, we're tracking how long does it take to create a pipeline. Because here, when we just define a code, we're creating this reactive pipeline, which will be executed later. So here, when we track time before and after, we track how long does it take for application to create this reactive pipeline, but not how long does it take to execute it, right? So it's also kind of interesting. So I made an investigation. There is a great library which calls GMH from Alexey Shapilov. He is now in Amazon in AWS. Previously, he was in Red Hat. And before that, he was in Oracle, one of the Java developers. So this GMH library gives you ability to measure time, to do real benchmarking with several runs and all this stuff. So we have this code. It's quite the same as we run. So we have a web client and get method, then URI method, accept, retrieve, body to mono, and map method. So how long does it take on each part to create? So if we have run number 1, so it's first run when we created this pipeline, method get took us 2 milliseconds. These numbers are in nanos. So it's 2 milliseconds almost. URI takes 6 milliseconds. Almost 2 milliseconds for accept, 6 milliseconds for retrieve, about half millisecond to body to mono, and something the same for map. Why so long? Because on each of these methods, there are a lot of constructors and caches filling because this is first run. So basically it's heating of your pipeline. So we create all this stuff and then we just like create it and put into the caches. Run number 2 numbers will be the following. So I will just show them. Well, they weigh less than on the first run, right? And it's just execution. So we just go reach this method, check cache, take this method from the cache, and just run it. For run number 3, numbers will be relatively same. One more interesting part, that if we'll have another pipeline, something like that, it's different from the first one, because in first one we have method get, here we have method post. URI, its method is the same, different URL inside. Body, we need to provide body for post method, then same accept, retrieve, body to mono, and map. So for the first run, numbers will be for post relatively small, as we already create one HTTP method. Creating second one won't be so hard. For URI, numbers are also comparable to run number 2 and 3 in first case. Sorry, I will drink some water. Yeah, so for body, it takes us a bit less than 1.5 millisecond. So it takes time because this method wasn't called in the first case. Then accept, retrieve, body to mono, and map, comparable to run 2 and 3 of the first case. And then run 2 and 3 of second case are relatively small, as we have in the first example. So interesting conclusion on that is that it takes time to create mono, so it's not free. When you do all this stuff, it's not like you just write some code and then it costs nothing. No, it costs. And basically what we can see here, the first run took us 21 milliseconds. So you should keep that in mind when you construct these pipelines, that maybe you need to hit it before first run, maybe you need to do something else, but still. Okay, we consider all this stuff, but still we have a task. We need to measure time. How long does it take for us to call another service? So let's do that. How can we achieve that? So basically, we need to measure this time after, not after we created pipeline, but inside the pipeline. So we would definitely know what's happening inside, and we have this time inside the pipeline. Okay, so we just need to introduce inside pipeline some new method. We have plenty of them. So for example, here we have do on next. I'm pretty sure ID is suggesting me here because it's not first time I do this talk, but still. Do on next means that after the previous section, we would do something else. So here we have result of our previous, all our previous steps. In this case, we won't use it, but we still have it. Unfortunately, we don't have kind of, S operator as in Scala. Yeah, so here we need to define some name. And then we just like put all this stuff inside pipeline. So we have it inside. And let me restart the service. So how our code changed, now we don't, like time before, it's still like when we reach this method, it would be the same. But time after, tracked after, we really do a call and process the result. So this is basically what we want to achieve. So let me run it. Run once. Any spoilers, guys? Maybe you can add something.
I will not.
Okay. Okay, so first call took us almost 2 seconds. Okay, I spoke something about like heating, all this stuff. Okay, 2 seconds is more close to truth than like 20 milliseconds, right? Second call took us like 1.5 seconds. And third call took us almost 2 seconds. Okay, like numbers are more close to truth, but still something strange, right? Because sleep there is from half of a second to 1 second, and here we have numbers about 2 seconds, like 1.5 seconds, 2 seconds. Thing is, and the secret is in this method map result, which I have here. So if I scroll down and open this method, you will see that here I also have thread sleep for 1 second. Of course, if this would be your real production code, you won't have thread sleep there, but you have the call to database, some processing, whatever. But thing is that we want to track exact time of how our call takes, but not how long does it take to process the whole pipeline. So thing is that we need to go inside our pipeline, insert here the method, like the same do on next, but after we do this like conversion from mono to string. So we have this mono and we convert it with do on next. And now we need to fix that. Here we also will have after. I will reduce nanos. We don't need them anymore. Time of the call and mapping here is like something in millis. And let me restart it. And it takes time to restart. Hope not so long. Yeah. And when we will execute it, I think once will be enough. You will see that now we have like time of the call is around like a bit more than 1 second. Okay, still pipeline heating, but then we have like a time of the call and mapping like plus 1 second, which we have in the mapping. So if we call it second time, then here we will see that second call really takes like just less than a second, and then like this plus 1 second, which we have like after the mapping. So these are real numbers of how long does it take for us to call the external service and then give a result back. So which conclusion can we have after this part? First of all, don't trust documentation blindly. Documentation could be written for not your version of framework. Documentation could not be adapted for some features you use in your framework. If you see some error, fix it, but always think of the things you Googled or ChatGPT provided for you, for example. So you don't need to trust it blindly. Always have a look at it, think of that, what you're doing there. Even if you benchmark something wrong, this is not always useless. For example, in this case, we now know how long does it take for us to create this pipeline, and now we may do some additional actions to prevent it, to make it faster, and all this stuff. So things are not free for use. You need to know that when you use it. And be careful with pipelines. So when you do something inside pipeline, always think of the parts where you execute something, where you do things. You need to be care of that as well. Okay, case number 3. I think we have time for this one, and then we will see how much time left for others. So case number 3, do it yourself, or why is there a sync? Basically, I need to put here a meme with Elon Musk and bringing sync into Twitter office, but I forget about that. So
was another thing.
Yeah, so we have a new shiny reactive service, and we want to subscribe for some events. So we want to subscribe for some updates which would come from this service, and then some update would come to the service, and we want to receive it as we subscribe for it. So let's see the code. When you are attending conferences, the thing you may hear there is like, just add a starter to your database. They support this reactivity, and you would be able to subscribe for data from your database directly to your table. So easy peasy, lemon squeezy. So thing is that if you want to do it manually, are not so straightforward, and you need to do some code and know stuff. So here we have method like add update. Add update, which calls method add new update. It's not implemented yet. And here we have subscription method for updates, which produces media type text event stream value. This is new, relatively new media type, which is supported by all modern browsers, which gives you ability to subscribe to the list of values and then listen for them like without breaking connection. You may think about WebSockets, you may think about something like RSockets. This is simple on HTTP level, so it's just establish connection between client and server and listen to the updates which comes from server. And we will return flux as mono returns 0 or 1 value, flux returns 0 or n values, so we need here to provide it. Okay, so the easiest way you may think of is, okay, previously I have mono and I called mono.just. Maybe I can do the same here. Okay, so we have flux. In flux, we also have method .just, and here we can provide some values. So let it be A, maybe, I don't know, B, no, not V, yeah, not Spanish, maybe C also, and I think D, yeah, it will be enough. So let me rerun application. It's rerunning. And yeah, let me call this this endpoint. Okay, we retrieve this data, A, B, C, D. Thing is that after we retrieved it, connection is closed. So our idea was to subscribe for some events and then receive them as updates are coming. But here connection is closed, so no more events we will have them. So this is not the way. So what is the way then? We need to define a special object which calls sync, which will provide us with data. So think of that as like a sync, a start of your pipe, and you created pipeline here. So you put a data or I don't know garbage into the sync, and then it goes through your pipeline to the outcome. Not a good comparison here because outcome is not like something nice and shiny, but still. So we would use this class syncs. We needed to create our sync basically. And here we have different options on which sync will create. As we use many values, well, obviously we need syncs many. And then we define like type of the object we would provide. And here we say like, okay, this will call updates. Also, I would like to have atomic long to be able to see that these are real updates, but not something pre-generated. Now we need to define a constructor and yeah, and inside this constructor, we would define what we have. So first about sync, right? Sync updates is, so syncs, we already see this class. Then we have options, same as we defined previously, so many. Then we want to define how exactly we want to cast these values to our subscribers. So unicast means that we cast one value, multicast means that we cast multiple values, replay means that we cast a lot of values and gives ability to subscriber to replay values. So see values which appears before they subscribe to us. Okay, in this case, we would use multicast. And then a lot of other methods. I don't really want to read documentation about them. Best. I see word best. I think this is the best option. Nice. We created some sync. So now we have this counter we defined. So we go here and say, okay, new atomic long. Cool. And then let's call several times add new update. So, okay, I think 3 will be enough. Now let's define our add new update method. So here we first of all want to receive some value from counter, get an increment. So here we would have like number. Then we would want to go to our sync, which we created, which it calls updates, and call a method which calls try emit next. So try emit next, this is the method which says, okay, this is the value, try to put it into the sync. So try emit next. And we say here like new update number plus and our counter which we created. And from this try emit next, we have the result of the emitting. And then I can say, okay, if result is failure, then let's log this. Log.error and say that like fail to emit and plus number. Okay, adding methods with adding is ready here. Add update is all good. And here now we need to return some flux. So basically, if we just check our updates, we have already these like as flux. So this is already done for us. Okay, let's see what we coded. Let me call these get updates. here you see it's like loading, so connection is established. So let me call several times this add update method. 1, 2, 3, and let's see here. Okay, we receive update number 3, number 4, number 5. Now, if I will go to, let's say, Safari and call here http://localhost 8090 / and I've localhost 8090, and let me check the API/reactive/update. To slashes, yeah, you see it's loading also. So it's not showing something, it's just loading. So let me add new update here. And you will see that we have update number 6 appears here, and it's still loading, right? It's the, like, you know, if you show something previously with Chrome, just continue showing this with Chrome. Don't switch between browsers because they can have different approach. Okay, it's loading here. Let me add one more value. It will be value number 7. Yeah, new update number 7. And in the Chrome, we see update number 7. So it appears. Okay, basically our task is done because we can subscribe for updates and then receive information about them when we do update. But what happened with our first 3 values we added here? If we have a logs on our application, we see 3 errors here that we failed to emit our value number 0, 1, and 2. And that's basically an issue. We want these values to be received by subscriber. Of course, your business logic could be different, and in your case, you may not want to be them to be delivered. But in our case, I want them to be received. The answer to this question in this method, direct best effort, because I choose that just because I see the word best. But thing is, if you open the documentation and if you read it, you will see that these, can I open it? Yeah, I can. So you may see here that without subscriber, like it's not the correct one. I need this one. So without subscriber, fail fast on try meet next. So if we don't have any subscribers, these just won't emit new values because nobody will receive them. So it just will be ignored and skipped. Same for direct all or nothing. The difference here, best effort, if you have many subscribers and some of them have errors, best effort will deliver the value to those subscribers who can receive them. Direct all or nothing, if some subscriber won't be able to like show a green light on receiving the value, it will just not deliver to anyone the value you emitting. So we want things to be delivered, so we have on back pressure a buffer option here, which says that without subscribers warm up, remembers up to some buffer size values. So we will use this one for our case. Let me restart the application. I will try to do it fast enough. So yeah, here connection is broken as our server is down still. So it's up. We're subscribing for our updates, and we see here our updates number 0, 1, and 2. Interesting thing that if we'll go to our Chrome, oh, by the way, Safari loaded value, nice. So if we go back to Chrome and we here will subscribe for updates, you see it's loading here. And if I call here add update, we see that here we received update number 3. And in Chrome, we also receive only update number 3 without first 3 updates. Because basically when we defined our sync, we choose here multicast but not replay. So new subscribers cannot replay values which were submitted before their subscription. Yeah, and only first subscriber receive everything which was in our back pressure buffer. So conclusion of this part is remember about your subscribers. Choose strategy depending on your task. Think of that, and your business logic could be different from what we do here. So think of that. And yeah, these are conclusions for this part. And I need to ask our organizers if I have time for other cases or I better to wrap up.
So I would like to say that we don't have any questions in the chat. So colleagues, if you have any question right now, it's a good time to raise up your hand, unmute yourself and ask the question.
before questions, then
yeah,
let me come to final conclusions. Yeah. So unfortunately, I have 2 more cases. You may check them in my full talk on our YouTube channel for subscription fee. No, it's free. It's free of charge, of course. So final conclusion on this topic, which I wanted to share with you. Reactivity is not scary, but you should be able to cook it. So you should know stuff. You should know where you can do something more precisely, more accurate. So you need to know how to do stuff here. Don't hesitate reading Java docs, as in our previous example. It could be not easy, and Java doc of reactive like WebFlux is not easy at all, but still it's worth to read Java doc if you don't know things. It will help you not to step on some rakes and not to have a lump on your on your body. And new things may be important to the old ones by parts. So here we see examples when we have old service and we develop just new service as a part of our system, and new service was reactive, but old one was not, and it will work. It's okay to do that. So you don't need to rewrite all your application to reactivity. You can do it parts by parts, as we have microservices mostly everywhere. That could be quite easy. Well, and good luck. Of course, good luck with your journey. And thanks for the attention. Link to my Twitter, link to our community. Thanking for having me here. And yeah, I'm ready to answer your questions.
So to be honest, we don't have any questions in the chat. So colleagues who are on the call, we have, by the way, we have many people on the call today who came to see you. It's 28 people.
Yeah, just unmute yourself and ask questions to Roman. But let me start these questions because I am from another world, you know. And what about if you're writing asynchronous, you call it reactive application? What about supporting reactive or asynchronous calls to the databases? Is it required support from drivers, or you can avoid it somehow?
Yeah, let me first of all do a separation like here between asynchronous and like reactive. So we have old bold threads which exist in Java from the very beginning, what you mentioned at the beginning of the talk. And from September, we'll have released Project Loom, which is basically virtual threads. You may think about that as a coroutines, kinda like some virtual threads above all threads. And now in between of these 2 points, like for 30 years, people tried somehow to solve the problem with threads because they were like huge. It was hard to create them. It took a lot of resources on this stuff. And this is how all this like reactivity part comes here. So this is basically not really async calls because they are more or less in sync, but still you may think of them as some like stage in between of fully sync calls and fully async calls, right? So you still can control them, put inside pipelines, but yeah, if we speak about paradigm, it's more or less async. Now about your question, yes, we have and we should have special drivers for databases, for storages to support these reactive flows. And for most of them, we have it already. As this WebFlux stuff is not like appears yesterday, it's for, I think, 5 years already here with us. We have drivers for, I think, all popular like databases, SQL and non-SQL, it's there and it's ready to be used. So it's not an issue. Well, if you use some proprietary database which doesn't support it, then yeah, you have problems. But still, if you use something like from normal world, it's not an issue at all.
Amazing. Thank you, Roman. Any other questions, guys? Please unmute yourself. Ask any questions.
I have a question. So it's a talk about rakes. It's a very provocative question. How to debug reactive pipelines in a comfortable way?
Yeah, well, not the first time I received this question. The answer is there is no way to do it in comfortable way. The most comfortable way is logs. So basically, when you do code and there is new method in the mono and flux like .log, so you may just like put logging into your pipeline. At least you would know what's happening somewhere in between. But still, if you write these reactive pipelines, it's really hard to debug them. It's really hard to just dive into it and see what's happening right in the middle. There is a nice talk from Sergey Yegorov. You may check it on YouTube. He showed a lot of stuff about that. You can add instructions to your Java code, which will add more logs about pipeline and how it works. Don't do this in production, never, because all these instructions will decrease performance of your application, as it adds a lot of overhead. But if you do it on your local machine, it's okay to add this flag, and then you will have more information in case you need to debug or see how it works internally. But yeah, basically it's a huge problem, and I think that's the why Project Loom appears, and these reactive pipelines are not full solution for like thread problems, and that's why we now will have virtual threads, because they will be much simple to debug and to see what's going on there.
Great, thank you very much, Roman, for answering the question. So colleagues who are on the call, I still encourage you to at least raise up your hand and ask questions.
Roman, quick question. Do you have any good sources to read about those pipelines, so to understand how this reactive model works under the hood?
Well, you may go just like check the instructions, like I mean, Google just something like Spring, WebFlux, and there are a lot of good examples, because Spring is support these things a lot. I personally think that the best source is Javadoc, because Javadoc and WebFlux is pretty good one, and well, it's hard to read, but it's good one. Because it has a lot of pictures describing your pipeline, what this method will do, like where it will send your request, etc., etc., etc. So my opinion is that yeah, well, Javadoc and WebFlux documentation itself is pretty good and speaking for itself. And also, if you don't know anything about like this reactivity, but you want to bring it, watch some talks from a WebFlux developer, from guys who are in this, like this talk also, just to at least have a starting point in this, to start doing something, and then like dig further.
Any particular talks?
Yeah, I already mentioned Sergey Yegorov. I think he had a good introduction. Also, there is Oleg Dakuka. They developed our socket, which is also good technology, like from technology point of view, good thing. And as our socket is tightly connection to reactive pipelines, he also described it internally how it works. Yeah, I think you may start from this one.
All right, thanks, Roman, and thank you for the presentation.
For the talk, yeah.
Yeah, you are welcome.
So another question from my side, yes. I saw you when you wrote code, you did some callbacks and closures and something like that. It's from JavaScript, there was concept like callback hell. Don't you know about it?
Well, I can imagine.
Yeah. So to be honest, in Python, it could be a similar problem. And a couple of years ago, maybe 5, 6, Python brings new syntax. I think await. Anything about it in Java? I believe that in JavaScript also exists this syntax.
Yeah. Thing is, and here I will redirect you to the talk I mentioned from Alexander Filichkin about Loom. There is 2 different paradigms how you can work with threads. One of them is async await, where you just define that, okay, this method should like be asynchronous or await, and then it will be executed by the system. And second option is virtual threads, when you don't mess with all the async awaits. Basically, I don't do any callbacks in my code. I just construct pipeline which do a call, and well, yeah, it looks like callbacks. I understand.
Man, you send closure to your method.
Thing is that you still have somehow to define how you work with like all this stuff. So if you speak about async stuff, it's not in Java, it's in Spring. So in Spring, you have special notation async. You just mark the method with async. You have to specify the return type of this as future, for example, and then you can subscribe for it. So basically, you do the same, but still you do callback stuff. right? So,
Same, yes.
but it's not Java. It's like one of
It's
the
great.
frameworks way.
Yeah, we already discussed in our previous meetups that Spring makes Java better.
Yes, exactly, and it sounds like you're not suffering enough when you write in Python. You should suffer more. To feel at least a piece of pain every Java developer is facing and experiencing writing reactive pipelines.
Yeah, exactly.
Yeah, I suppose we have to move forward. Thank you very much, Roman.
Thank you, Roman.
For your
Thanks for having me.